that are very crucial for us to select. Okay, so I have listed here a few, and there are of course few more, but this the one I'm listing is the most important part. Okay, we start with the nominal current, and then the breaking capacity, the magnetic strip types, and the poles. Okay. For nominal current, okay, this is very crucial to ensure that the breaker will be able to protect your electrical system. Failure to observe and to select the correct rating will cause overloading, okay, where your electrical system will be exposed to additional currents, okay, or overload currents. And for breaking capacity, if we fail to select the correct breaking capacity, when there is a real short circuit happening, then your breaker may not be able to clear the fault, but instead the breaker itself may explode due to very high PSCC intensity. It's okay to size higher, but it is dangerous if you undersize your breaking capacity. So that is why it is very, very important for us in the design to calculate the PSCC. Okay, how far we are from the transformer and what is the PSCC at the secondary winding of the transformer. So all this has to be calculated and to come up with the PSCC at the point of the breaker installations. And again, besides the PSCC itself, you need to also understand the different types of breaking capacity of breakers. Okay, I put here ICN, which represent nominal breaking capacity. But beside ICN, we will have three more, which is ICU, ICS, and ICW. Okay, which stand for ultimate breaking capacity, serviceable breaking capacity, and short-term withstand breaking capacity. For MCB, it is very simple. You just need to know about ICN. But once you use MCCB, ACB, you need to know the other three. And magnetic curve. Okay, for MCB, it's a very basic. The most common one is BCD, unless you use a very specific dedicated circuit breakers with type K or type Z, but that are for very niche applications. But the most common one are BCD. By understanding this BCD curve, you should be able to apply to a more complicated design where you need to play with LSI, long delay, short delay, and instantaneous stripping. Okay, before we go into LSI or adjustable MCCB and ACB, let's us discuss about these basic curves, so that once we know about these basic curves, we can apply the concept to the much more complicated and complex setting of LSI and LSIG. Okay, I purposely put here again the selection of poles because until today I can see in drawings there are still a lot of people putting SPN and TPN in the drawings. Okay, I purposely omitted the SPN and TPN because I do not want you to be confused. Remember, I was telling you what is the difference between one pole, two pole, and SPN. They are in different types. Same with 3-pole, 4-pole, and TPN. There are three different types. They are not the same. Right, we go for nominal current first of all. Okay, this is where it is written. Here is 16 amps. The breaking capacity 10 kA in this particular example. The curve is type C. pole here is 2 pole. You can look at this poles or at the symbol here. Okay, the symbols here is also shown the number of poles. Why it is 2 pole? If you look at the symbols, both are protected. This is all symbols. Okay, the overload protections and the short circuit protections are clearly shown in the symbol. Today I will not touch much on the energy let through and the energy limiting class. Okay, the reason is because today all breakers, all MCB manufacturers are already complying with this energy limiting class 3. Okay, not like in the olden days, some are still class 1, some class 2, but now everyone is already complying with class 3. So I think I don't need to discuss much on the energy limiting class. Okay, now parameter number 1, nominal current, IN, or rated current. In the IEC, they use the word nominal current, or IN. Okay, we can also call it as a rated current. Okay, be careful in our design. Sometimes we overlook, accidentally we put values which are not standard. Okay, be careful, because this will reflect about how people evaluate you. For example, if you use 30 amps breaker, people will look at you as if you are not really professional, because there is no such thing as 30 amps breaker. It only exists as a 32 amps. Same with 60 amps breaker. So be careful not to put 60 amps, because there is no such thing as 60 amps MCB or MCCB. The only one that exists is 63 amps. So these are the standard values. Okay, from 0.5, 1 amp, 2 amps, 3 amps, 4 amps, and so on. And I put here 2 in red colors. Okay, the 8 amps and the 13 amps. Though these 2 values are standard values, but not so far, I can't say not many, but I can say no one so far produced. I'm not sure, but you can check. Okay, if you find anyone producing 8 amps, let me know. But so far, in my experience, in my observation, I could not find anyone producing an 8 amps breaker and 13 amps breaker. But they do exist in the standard as a standard value. So the IN is selected based on the cable that you are going to protect. If the cable is, example, 1.5 square mm, then your breaker should not exceed 10 amps. If your cable is 2.5, then your breaker should not exceed 20 amps. So this is very, very important for you to know what your cable current capacity and your breaker nominal current, to make sure you are protecting the cable. Okay, alright. Now, next will be a quiz. So everyone, please get ready. Right. The quiz will be what you call posted for about 1 minute, and you need to answer within the specific time. And the answer has to be sent via WhatsApp to Miss Fatin. Do not answer the quiz inside the chat box. Okay. And we will evaluate who get it right. The first person who got it right, and then at the end of the day we will check your individual points, and the highest people, the 2 highest, we will give them some hadiah present. Okay, small one, not big one. Okay, not ACB or MCCB, it's just small token of appreciation. Alright, get ready guys. The question is, okay, this is the first question. I already gave you the answer, but this is just to what you call, to start the quiz for today. Okay, 40 seconds from now.
Kabel saya 2.5 mm. Okay, 2.5 mm.
Please send your answer to Miss Fatin by using WhatsApp.
The maximum current 24 am. M. Maximum MCB.
Okay, time's up. Okay, the answer is 20 amps, right?
20 am.
Okay,
Yeah.
those who have sent your WhatsApp, okay, Fatin will check who is the first person with correct answer.
MCB berapa kalau maximum current?
Okay, maybe I'll check with Fatin. Fatin, do we have a winner for this first quiz?
Oh, dia kurang sikit pada
Alright, okay, we have already a winner for this. Maybe I would like to.
Provide number, name.
Oh, sorry. Fatin was asking everyone. Once you send your WhatsApp, please also send your name, because Fatin do not have your contact. Please, when you send the answer, please also send your name, so that she will know who is actually the person. Right, we done with the first quiz. There will be about, altogether, I think is about 10 to 12 questions throughout the day. Okay, this is another rule of thumb where we need to ensure that the rule is complied, where your load current must be lower than your breaker current. Otherwise, every time you switch on, your load switch on, your breaker will trip. And your breaker current must be lower than your current carrying capacity, your cable current carrying capacity. Okay. So if your load is 30 amps and you use a if your load is 30 amps, you use 32 amps breaker. That's okay. And your cable should be more than your breaker rated current. So in this case is 6 mm, where if installed direct clip, it can carry up to 46 amps. Okay. Alright, please take note that the IZ here, you must take care of all the correction factor, the grouping factor, the heat dissipation factor, the insulation factor, okay, before you come up with the cable size itself. And of course, the other one is the voltage drop factor. Now let's talk about the second parameter is on the breaking capacity. Okay, we will touch a bit on the ICU, ICS, ICW later, but let us first discuss on the nominal breaking capacity. For MCB, the nominal breaking capacity is as small as 3 kA up to 25,000 amps. Okay, people, okay, maybe some young engineers, you would like to know why this high current, why this few thousand amps current during short circuit, where it comes from. Alright, so let us back to our basic electrical law, okay, where everyone should know this Ohm's law. I made a bit of change here. Normally for Ohm's law, we say V equal to IR. But I made a little change here where I changed V to U. Instead of using V, I change it to U. Why? Because V is actually unit for volt. Right? V is not a symbol of voltage, but V is actually a unit, a volt, a symbol for volt. Where voltage in any what you call articles today, especially by IEC, is represented by U. Okay, U stands for potential difference, okay, which is voltage, and it's not V. V is unit. So U equal to IR. Okay, this is the simple circuit. When you have some amount of current passes through a resistor, then you will have a voltage. Or the other way around, if you have a voltage of certain amount passes across a resistor, you will have a certain amount of current. But during short circuit, like this, the impedance between this point to this point is no longer this R, but is actually approaching zero. Okay? When there is a short circuit, your R, the potential difference between this, the impedance between this is almost zero. So R is approaching zero. When R is approaching zero, it means that the voltage now is divided by a number which is approaching zero. Okay, I think you all know what will be the result. Once R is approaching zero, then I will be approaching infinity. Okay, that is why during short circuit, you will have I very, very high, in thousands of amps. The only limit is your transformer capacity, how much power your transformer can deliver. That is the limit. Okay. Besides, of course, the cable impedance between the transformer and at the fault point. Right, so that is why during short circuit, the PSCC is very, very high, because basically the impedance between the line and neutral is approaching zero. Okay. Now, what is ICU, ICS, ICW? This is the rating on the breakers to tell the users how much the breaker can withstand fault current. Okay, ICU is the ultimate braking capacity. As a basic of design, once you calculate your PSCC, your breaker ICU must match that PSCC or more. Okay, I repeat, as a basic of design, once you calculated your PSCC, you get the value, your ICU or the circuit breaker must be the same or more compared to PSCC. Right, that is the basis. If your breaker ICU is less than PSCC, so there will be probability, there will be tendency that your breaker may not be able to clear the fault during short circuit. Okay, so ICU is the ultimate, the highest rated value for the braking capacity in any circuit breaker. Okay, now your next option is to choose what ICS value in terms of percentage of ICU. Do you want your ICS to be 100% ICU? ICS equal to just 75% of your ICU, or can be 50% of your ICU. It depends on your budget. Of course, if you have got the money and the customers don't mind to spend, then you put ICS 100% ICU. Okay, it means that your breaker can withstand the PSCC many times without you to worry. But once you select the ICS, maybe 75% or 50% of ICU, so every time there's a fault, when the breaker trips, you need to check to confirm that your breaker is still okay to be used again and be able to clear the fault should there be another short circuit. Okay, and then ICW is only applicable if you need to do discrimination between the upstream and downstream breaker with delay. For example, if you have ACB upstream and then you have MCCB downstream of more or less the same rated current, but to ensure that when there is a fault downstream, the breaker downstream will trip first, you must make sure that your ACB upstream has a built-in adjustable delay where you can set the delay maybe to 0.5 seconds, 1 second, 2 seconds, depends on your discrimination level. And your breaker then must be able to withstand the fault current during that delay. Let's say it's 1 second delay. When there is a fault, your circuit breaker must be able to hold on to the fault current for that 1 second. Okay, that it means by ICW. Okay, I hope I'm clear with the explanation of ICU, ICS, ICW. Of course, if I were to discuss on more detail on ICU, ICS, ICW, it will not be enough for the whole morning, because it takes what we call a very lengthy explanations on the selections of all these breaking capacity. Okay, question number 2, 40 seconds from now. Very simple. A DB located about 200 meters away from your transformer, and by calculation the PSCC is 12,000 amps. If you are going to install a breaker, then what will be the ICN of this breaker? Okay? Please send your answer to Miss Fatin via WhatsApp. Thank you. Okay, time's up. We have got few people answering the question. Thank you again for your participations. Because okay, we need why we put this quiz, because we need you to participate so that we know that you all are actually listening. You all are there, okay, following the seminar. Okay, that is the challenge in conducting webinar, because you can't see your audience. I cannot see you. Okay, what you are doing behind the screen. Okay, I do not know. And if it's live presentation, is easier because we can see the audience in front of us. And furthermore, in conducting live webinar like this, speakers, presenter is actually under stress, because you need to continuously speak. Unlike in live presentation where your hands can speak, your body can speak. But during online presentation, you must always keep on talking to ensure that people will know the seminar is still ongoing. Okay, that is a challenge. And it's more tiring. Okay, I tell you the truth that it's more tiring conducting webinar compared to conducting live seminar. Okay, Fatin, have you got the answers, people? Okay, thank you very much. We have few answers already.
Mana?
Right, looking at the question, if the PSCC is 12 kA, means that your breaker must be the same or higher. But if you look at the breaking capacity of MCB, there is no 12 kA, but the next highest is 15 kA. So that is the answer. Okay, as I explained earlier, it's important to understand these curves, the B curve, C curve, and D curve. Because if we are not able to understand and to select to use it properly, then it will be difficult for us to understand the LSI and LSIG concept in MCCB and ACB. So that is why normally when people, when I'm presenting on LSIG selection, I will start with the BCD curve first. Okay. Unfortunately, there is no A. Otherwise, we can say we start from ABC. But for magnetic curve in circuit breakers, there is no type A. So you start from B, C, D. Otherwise, you can use ABC. We start from ABC. No, we start from B, C, D. Okay, so how to use this BCD? B and C and D. MCBs in general are divided into these three different categories: the B curve, C curve, and D curve. B curve is the most sensitive, C in the middle, and D is the less sensitive. When I say more sensitive, less sensitive, in terms of what? In terms of detecting how many times IN. If a breaker is 10 amps, the IN is 10 amps. Then type B will start to trip if it detects 3 times IN, which is 3 times 10, 30 milliamps. That's what 30 amps. Okay, and C will only start to trip if the fault current exceeding 5 times IN. And D will wait until the fault current exceeds by 10 times of IN. So this is the example here. Okay, IN of 10 amps. For type CD, lower limit is 5 times 10 and the upper limit is 10 times 10. Okay, so how it looks like. Okay, if you draw the tripping curve on a log scale chart. Okay, this is a log scale chart. This is not a linear scale chart. It's a log scale chart. The circuit breaker tripping curve always consists of at least 2 different curves. Okay, the thermal curve and the magnetic curve. Okay, if you look at this black curve, here is the thermal curve, and the straight one is the magnetic curve. The thermal curve is to show the response for overload protection. The straight curve is to show the response of the breaker during inrush current. Okay, inrush can be starting current, it can be also short circuit current. Okay, and it has lower limit and upper limit. Okay, lower limit means if the current flowing through the breaker is below this lower limit line. Below means it's somewhere here. Okay, let's say somewhere here or somewhere here. The breaker should not trip at all. If your breaker trip below the lower limit, then your breaker is failed. Okay, your breaker has failed to protect. And if it detects current between the lower limit and the upper limit, okay, so let's say somewhere here, in the middle, at this point, your breaker may trip. I'm not saying must, but I said may trip. Okay, may trip because it is still within the below the upper limit, within the lower limit and the upper limit. But once your fault current touches the upper limit, then it is a must for the breaker to trip to isolate the fault. Okay, so that is how you read a tripping curve on any circuit breaker. Okay, so let's say you test a breaker and you say, let's say here is C32, type C32 amps. So the lower limit is 32 times 5, which is 160. The upper limit is 32 times 10, okay, 32 times 10, which is 320 amps. Okay, so this is the lower limit and the upper limit. If there is a current of 200 amps, for example, and your breaker doesn't trip, so it's okay because it's yet to, it's still not yet touching the upper limit. Okay, this is on the inrush current, okay, on the magnetic tripping. How about on the overload tripping? At what value will your breaker start to trip? Okay, and I also shown you here the red curve. Okay, this red curve is to represent your load, your starting current and your running current. Make sure when you design a system, you design an electrical system, your load should not touch any part of this breaker curve. If your load starting current or your load running current touches any part of this breaker tripping curve, then your breaker may trip during the operation. So that is why it is important for us to plot your load current and your breaker current, your breaker tripping current, to ensure they are not touching. And secondly, please keep your overload protection as close as possible to the load running current. Okay, this is good in order to protect your load, for example, motor load or anything, because sometimes the load is expensive. Your electrical loads like what you call machines and which are expensive, especially the motors. So make sure your overload protection is as close as possible to the running current, and your instantaneous tripping, your magnetic tripping, okay, must make sure it is not within the starting current. Okay, not within the starting current. Otherwise, when you start your load, it will cause nuisance tripping. Okay, these are the two important parts. First, I said the running current must be as close as possible with your overload protection. Your starting current must be your instantaneous tripping curve must be away from the highest starting current to ensure no nuisance tripping during starting. Okay, that's all about the concept of magnetic tripping curve. Now is the questions. Okay, 40 seconds from now. Please send your answer to Miss Fatin. Which tripping curve type is suitable for welding machine? Okay, welding machine is well known for very high starting current. Every time it starts to what you call use the welding machines, every time it sparks, it will have a very huge inrush current. So the question is, which one is the best? I'm not saying which one can be used. Depends on your aims, but which one is the best? Alright, time's up. So when talking about which one is the most suitable, is of course type D. Okay, this is to avoid unnecessary nuisance tripping during operation. But sometimes people upgrade to higher ends. Okay, that is the one I would like to address. Do not upgrade your breaker rated current unless you know what is the maximum cable carrying capacity. Some people using 2.5 square mm cable but using 25 or 32 amps breaker. Reason, they say, oh, every time you on, it trips. So this is a very, very wrong way of doing things. Very unprofessional, and this is very dangerous. Because once you upgrade your IN, your nominal current rating of the circuit breaker, exceeding the rated current of your maximum current capacity of your cable, means that you are no longer protecting your cable. So anything when there is an overloading, your breaker will not be able to protect your cable, and one day the whole building will catch fire. Okay, that is very, very important. Do not upgrade your breaker rated current unless you are sure that it is still below the maximum current capacity of your cable. In general, this is just a guide. Normally, you use B for socket outlet, so any general use circuit. But unfortunately, in Malaysia, we do not use B for socket. Okay, but if you are designing a system for Hong Kong, for Singapore, be careful. It is mandatory for Singapore, Hong Kong. Socket must be type B. In some European countries also, socket, they use B. Why they use B? Because B is the most sensitive, as earlier I mentioned. And this is also to protect, be able to provide additional protections to your household equipment. Okay, your blender, your mixer, okay, all these equipment are sometimes very expensive. If you are using Type C, the tripping could be delayed, okay, for a few milliseconds, and that during that time your appliance may be already damaged. So that is why some countries already what you call making mandatory sockets to be protected by Type B. In fact, locally also JKR already asking for Type B to protect sockets. Okay. Wow, thank you very much, Sifu Leong Kok Wah. You can see the comment from Sifu Leong Kok Wah from PKPPE, from Ipoh Mali, Mr. Leong. Mr. Leong is my Sifu lah. He's a great man, always sharing his technical finding among the what you call electrical practitioners, electrical engineers and practicing engineers. He is using Type B for the whole house. Wow. CC ni Mr. Leong. Okay, whereas Type C is okay to be used for any other than socket. For example, lighting, fans, lighting, aircon. Okay, you can use Type C. And Type D specific for high inductive or high capacitive switching. Okay, transformers, welding machines, and all other high inductive and high capacitive switching. Even like what we call this spotlights, stadium spotlight, they're using sodium vapor technology and all this, where they have a very high starting current. It's good to use Type D. And it's also good in your design for all the incomer. For all the incomer, let's say you have a 63M 2-pole breaker as incomer, it is recommended to use Type D for discrimination purposes. Okay. Why recommended to use Type D? Because there are a lot of cases, incidents, when there is a short circuit at the final circuit, maybe your jug kettle is faulty and the heating element is shorted. Not just blowing the fuse at the plug top, it also trips the outgoing breaker and even the main incoming breaker also trips. So it shows that there is no discrimination between the 13 fuse, the what you call maybe the 15 amps or the 20 amps outgoing breaker, and even the 63 amps or 40 amps incoming breaker. Why? Because the wrong selections of this Type B, C, and D. That's why I always recommend for incoming, always use D, so that it will only trip if the downstream breaker has failed. Okay, to ensure that the whole house will not get blackout, tripping the main breaker is by having certain percentage of discrimination by having or using Type D as the incomer. Okay. Right, so this is the application of curve. Why we use BEC and D mainly is to avoid for unintentional starting current, okay, in rush of starting current for motors, transformers, and secondly is for you to achieve a certain degree of discriminations. Okay, when I talk about discriminations, we are talking about upstream and downstream circuit breakers in series. If you have two circuit breakers in series, one is upstream, one downstream, one is incoming, one is outgoing, you make sure the their curves, the tripping curves are not overlapping. The what you call this, the upper limit of downstream, the upper limit of your downstream breaker is not touching the lower limit of your upstream breaker. Okay, if you look at these two, the red and the yellow, make sure the upper limit of your downstream is not touching the lower limit of your upstream breaker. Okay, that is crucial to ensure to achieve discrimination. If they happen to overlap between the downstream and upstream, when there is fault downstream, both breaker may trip. Okay, both breakers may trip. Sorry, one minute, I forgot to off. Sorry.
Habis kita buat ni dah memang tak kacau lah. Kalau nak kacau tu berlaku pelanggaran ke apa lah. Tu lah. Macam tu lah. Macam yang aku tengok dekat DC 1-2 kan. Kata silap aku dah tahu yang